Right now, as you watch this, you are moving. Not because you're walking or driving, but because the very ground beneath your feet is actively drifting across the surface of the Earth. What feels like solid, permanent, unbreakable land is actually part of a gigantic floating slab of rock, constantly shifting, sliding, and grinding across a planet that is very much alive. We build our cities and our civilizations on the assumption that the Earth is static, but today we're going beneath the crust to meet the secret giants, the massive, invisible tectonic plates that are quietly rewriting the map of our world, just as they have for billions of years. When you step outside, Earth looks completely solid. The mountains seem eternal, and the continents feel permanent. But this stability is nothing more than an illusion created by the shortness of human lifespans. We experience time in decades, but Earth operates on geological time, spanning billions of years. In that grander timeline, the landmasses we call home are enormous, fractured pieces of Earth's outer shell, drifting along a vast hidden ocean of superheated rock. They are in a constant state of motion. But if the ground beneath us is moving with such incredible force, why don't we feel it? To answer that, we have to journey deep inside the planet. Beneath Earth's brittle outer crust lies a massive layer called the mantle. While many think the mantle is liquid magma, it is actually mostly solid rock. However, it is incredibly hot and under such immense pressure that it behaves like a very slow-moving, flexible putty. Deep down near the center of the Earth, intense heat from the core warms the bottom of the mantle. As this rock heats up, it slowly rises toward the crust. Once it reaches the cooler upper layers, it cools down, becomes heavier, and sinks back toward the core. It works exactly like a colossal lava lamp or a boiling pot of thick soup. These massive churning loops are called convection currents, and they are the hidden, unstoppable engine dragging the surface of our planet. But what could possibly be strong enough to move an entire continent? Meet the secret giants, Earth's tectonic plates. Our planet's rigid outer shell isn't one unbroken sphere. It's shattered into massive puzzle pieces. There are 7 major tectonic plates, like the Pacific and North American plates, along with dozens of smaller ones. These giants are incredibly powerful, carrying entire oceans on their backs, but they are also incredibly slow. On average, they only move about 2 to 10 centimeters every year. To put that into perspective, tectonic plates travel at exactly the same speed that your fingernails grow. It seems insignificant on a daily basis, but when you add up those microscopic movements over millions of years, they possess the power to completely change the face of the Earth. So what happens when these unstoppable giants crash into each other? At convergent boundaries, plates collide head-on in a slow-motion battle of epic proportions. When 2 massive continental plates smash together, neither one wants to sink. With nowhere else to go, the Earth crumples, folds, and pushes upward to build colossal mountain ranges. The Himalayas, the tallest mountains on Earth, formed exactly this way when the Indian plate slammed into the Eurasian plate about 50 million years ago. Before the collision, the space between them was an ocean, which is why you can actually find fossilized marine seashells at the peak of Mount Everest. And because the plates are still relentlessly pushing together today, the Himalayas are actually growing taller by a few millimeters every single year. If you're enjoying uncovering the hidden forces that shape our world, hit the like button. It helps QuestHut reach more curious minds. And if you love exploring the science behind everyday mysteries, make sure you're subscribed because we've got plenty more big quests coming your way. We know these plates can build towering mountains, but what happens when they get stuck? Not all plates collide head-on. At transform boundaries, plates slide sideways past each other. However, the edges of tectonic plates are not smooth. As they try to slide, friction causes their jagged edges to lock tightly in place. For decades or centuries, the massive convection engine in the mantle keeps pushing, stretching the rock like a giant rubber band and building up unimaginable amounts of stress. Eventually, the rock can no longer handle the strain. When it finally fractures and the locked plates violently snap into their new positions, that pent-up energy is released all at once. The result? a devastating earthquake. The friction of tectonic plates doesn't just shake the ground, it brings fire from below. When a dense oceanic plate collides with a lighter continental plate, the heavier ocean plate is forced down or subducted into the fiery mantle. As the sinking plate descends, it drags seawater down with it. This water lowers the melting point of the surrounding rock, turning it into highly pressurized, bubbling magma. Because this magma is lighter than the solid rock around it, it violently forces its way back to the surface, melting through the crust to create explosive volcanoes. Nowhere is this more obvious than the Pacific Ring of Fire. This 25,000-mile horseshoe-shaped boundary traces the edges of the Pacific Ocean. Here, constant tectonic subduction creates a volatile zone home to 90% of the world's earthquakes and over 75% of its active volcanoes. While it might seem like tectonic plates only destroy, they are also constantly creating new terrain. At divergent boundaries, plates are actively pulling apart. As two plates separate, a massive rift opens and fresh magma rises from the mantle to plug the gap. When this magma meets freezing ocean water, it cools instantly, forming brand new crust. This process happens deep underwater at mid-ocean ridges, the longest mountain ranges on the planet, hidden entirely beneath the waves. You don't always need a submarine to see this happen. In Iceland, the mid-Atlantic ridge actually rises above sea level. You can literally scuba dive in the Silfur Fissure, swimming in glacial water right between the North American and Eurasian tectonic plates. Meanwhile, on land, the East African Rift is currently pulling the African continent apart, which will eventually create a brand new sea. Because new crust is always forming and old crust is always being destroyed, Earth's continents are on a never-ending road trip. Around 300 million years ago, almost all of Earth's landmasses were mashed together into a single massive supercontinent called Pangaea. This explains why the coastlines of South America and Africa fit together perfectly like giant puzzle pieces. Over millions of years, the secret giants tore Pangaea apart, slowly dragging the shattered pieces across the globe to form the map we recognize today. But if the plates have moved this much in the past, where exactly are they taking us next? The journey is far from over. Because the convection currents in the mantle show no signs of stopping, millions of years from now, our current world map will be entirely unrecognizable. Scientists project that in about 250 million years, the continents will once again crash back together. The Atlantic Ocean will likely close up completely, and a brand new supercontinent will form. The geography of our world is just a temporary snapshot. The map you studied in school won't exist forever. It's easy to think of plate tectonics as a distant geology lesson, but these secret giants are the primary reason we are alive today. Tectonic plates act as Earth's global thermostat. Through volcanic eruptions and the weathering of new mountains, the carbon cycle is regulated, keeping our climate stable. The shifting of continents alters ocean currents, which drives weather patterns and forces life to adapt and evolve. Even deep underwater, tectonic rifts create hydrothermal vents that spew mineral-rich heat into the freezing dark, environments where many scientists believe the very first life on Earth may have begun. Without tectonic plates, Earth would be a stagnant, frozen rock. The next time you walk outside and stand on what feels like solid ground, take a moment to remember, it isn't as solid as it seems. Beneath your feet, giant tectonic plates are still drifting. Ancient mountains are still rising toward the sky, ocean basins are still expanding, and the magnificent map of Earth is still being actively rewritten. Earth's surface isn't permanent, and it isn't static. It is a living, breathing, ever-changing masterpiece shaped by the slow, relentless power of invisible giants. We are merely temporary passengers, witnessing just one fleeting, beautiful moment in a 4.5 billion-year-old story that is still being written. If this video changed the way you see our planet, let us know in the comments. Which tectonic fact surprised you the most? If you enjoyed this epic journey beneath Earth's surface, don't forget to like, subscribe, and share this video with someone who thinks the continents never move. Until next time, stay curious with QuestHut, because every answer leads to another quest.